Hi everyone, this is Miss Helms, and we're back for video number 2. So by the end of this video, you should be able to solve for missing side lengths of similar polygons, and you should also be able to determine the scale factor between two similar polygons. Starting with our first problem, it says to state the corresponding side parts. So it's really asking which sides match up with which sides from the bigger quadrilateral to the smaller quadrilateral. So taking a look, let's start with AU in the larger quadrilateral. AU in the larger quadrilateral corresponds with VI in the smaller quadrilateral, or these two sides match up. So to write this, what we're going to write is a statement of proportionality, or it's a statement where we set the ratios of all of our corresponding sides equal to each other. So AU over VI is equal to our next corresponding sides would be UQ and IF. UQ over IF. And notice how I'm keeping the order consistent. Since I put the larger quadrilateral in the numerator in the first ratio, I'm putting the larger quadrilateral side in the numerator of the second ratio, and so on and so forth. The next side would be QD. It corresponds with side FE. And last but not least, we have DA corresponds with EV. So again, this is a statement of proportionality. We have matched up all of our corresponding sides and set them up as ratios that are equal to each other. The second part of this question says, state the scale factor from quadrilateral QUAD to quadrilateral FIVE. So to do this, we need to look at any values that were given of the side lengths to write the scale factor, which is a ratio between the larger quadrilateral to the smaller quadrilateral. So taking a look, we know that QU is 6 units and FI is 3 units. So writing a ratio of quadrilateral QUAD compared to quadrilateral FIVE, we have 6 over 3, which we always want to simplify, reduces to 2 over 1. So the scale factor from quadrilateral QUAD to quadrilateral FIVE is 2 to 1. Next, we are looking to find X, Y, and Z. So to do this, we're going to set up proportions to solve for the missing lengths. To set up proportions, all we need to do is match up the corresponding sides. So starting with what we know that QU and FI correspond. So we're going to use that as one of our ratios. We can always use our scale factor as a ratio, but I'm going to use our side lengths so that we can match up the corresponding pieces, but you'll get to the same answer either way. So 6 over 3 is equal to, we want to match up our corresponding parts, so X corresponds with 8. So since we chose the larger quadrilateral first, we're going to put the larger quadrilateral on the top. So 8 over X. Now to solve this, we are solving a proportion, so we're using cross multiplication. So using cross multiplication, we get 6X is equal to 24, and therefore X is equal to 4. Now we want to solve for y, and we're going to solve for y the exact same way. We want to set up a proportion. So I'm going to go back and use the same proportion. We're going to do 6 over 3, but this time I'm going to show you it doesn't matter if you do 6 over 3 or 3 over 6 as long as your order stays consistent. So instead this time I'm going to go 3 over 6 is equal to, well, let's see, we have 5 corresponds with y. So since the numerator in my first ratio is from the smaller quadrilateral, the numerator in the second ratio should also be from the smaller quadrilateral. So 3 over 6 is equal to 5 over y. To solve this, we're going to go ahead and cross multiply. So 3y is equal to 30. and therefore y is equal to 10. Last but not least, we're trying to solve for z. So taking a look, we know that z corresponds with 9. And this time I'm going to use our scale factor. Because remember, you can use a mix of any of these, or you can keep it all consistent. I'm just showing you that there are many ways to solve this problem. So using our scale factor of 2 to 1, 2 over 1 is equal to, and now 2 over 1, so we're going from bigger to smaller, which means our larger quadrilateral should start on top, so 9 over z. To solve this, same way, we're going to cross multiply. So 2z is equal to 9, so therefore z is equal to 4.5. So this is how you solve for missing side lengths. But there is one more question. So if we turn to the last part, it says find the ratio of the perimeter of quadrilateral QUAD to quadrilateral FIVE. So to do this, we are going to find the perimeter of each. So the perimeter of QUAD is the sum of all the sides. So we have 8 plus 6 plus 9 plus 10, which gives us a total sum of 33. And then we have the perimeter of quadrilateral FIVE, which is equal to 5 plus 4.5 plus 3 plus 4, which is equal to 16.5. And the question is, find the ratio of the perimeter of quadrilateral QUAD to quadrilateral FIVE. So I'm going to put QUAD in the numerator and FIVE, the perimeter, in the denominator. And I'm going to simplify this. 33 over 16.5 simplifies to our scale factor of 2 over 1. Nice work.